Okay, we're going to go over the derivatives in-class worksheet for part B. Okay, here's where the fun begins. All right. This really is the first major topic of calculus. Okay, calculus really only has two major topics, and this is one of them. So we're going to have some fun with this. All right, number one. If f of x equals 3x squared minus 7, well, what's the derivative of that? F prime of x. Bring the 2 down in front, multiply by 3, subtract 1 from the exponent, and we're left with 2 times 3 times x to the first power. And remember, anytime we have a constant, the derivative of that is just 0. So we're left with just 6x. All right, this one I think we did in class. We'll do it again real quick. 1 over x squared, the derivative of that. Well, we're going to put the x into the numerator and call it x to the negative 2. So bring the negative 2 down in front, subtract 1 from negative 2, and we have negative 2 times x to the negative third power, which we could write as negative 2 over x cubed. Number 3, I've got the square root of x minus 2. Well, I'm going to take the derivative of that, and I'm going to write the square root of x as x to the 1/2. Pull the 1/2 down in front, subtract 1 from 1/2, and that gives me a negative 1/2. The derivative of negative 2, it's a constant, is just 0. So I've got 1/2 times x to the negative 1/2, and I could write that as 1 over 2 times x, the square root of x. All right, let's take a look at this polynomial here. I've got f of x equals 8x squared minus 3x plus 4. And I'm going to take the derivative of that. Well, 8x, it's going to be 2 times 8 to x to the 2 minus 1 power. So that's going to give me 16x to the first minus 3x, 3 times 1 times x to the 1 minus 1. Well, that's just 1, so that's going to be negative 3 times 1 is negative 3. So I've got 16x minus 3. Again, the 4 derivative constant is just 0. All right, number 5 is a little trickier here. I've got x plus 2 divided by the square root of x. Well, I've got f of x is equal to, I could rewrite this as x over x to the 1/2 plus 2 times 2 over 1 to the 1/2. And I could write that as x to the x to the first times x to the negative 1/2 would give me x to the positive 1/2. 2 times x to the negative 1/2 would look like that. Now I can take the derivative of it. Pull the 1/2 out in front, subtract 1 from the exponent, gives me negative, gives me 1/2 times x to the negative 1/2. Plus, here I'm going to take the negative 1/2 in front, multiply it by 2, and then times x to the negative 1/2 minus 1. Well, the 2's are going to cancel out here, and I'm going to be left with 1/2 x to the negative 1/2 minus, because of the negative here, x to the negative 3/2. And I could rewrite that as 1 over 2 times the square root of x minus 1 over the square root of x cubed. Take a look at number 6. I've got the cube root of x squared. Well, I could rewrite that as x to the 2/3 power. Taking the square root, taking the derivative of that, I'm going to bring the 2/3 out in front, subtract 1 from 2/3, and I have 2/3 x to the negative 1/3. I could rewrite that as negative 2. Uh, that should not be a negative. That should just be a positive. It should be 2/3 over the cube root of x. Number 7, I'm going to divide this one up again. I've got x cubed minus 8x divided by x squared. Well, I could write that as x cubed over x squared minus 8x divided by x squared. And that would leave me with x minus 8 over x. Or I could rewrite that as x minus 8 times x to the negative first power. Now I can take the derivative of that. The derivative of x is just x to the 0, or just 1, minus, here I'm going to take the negative 1 in front. Negative 1 times 8 to x to the negative 1 minus 1 is just 0. I'm sorry, negative 2. So I have x to the 0 plus 8 to the x times to the negative 2 is equal to 1 plus 8 over x squared. Number 8, here I've got a polynomial in this form, 9x squared plus 7 minus 3x to the negative 2. Again, pull the 2 down in front, subtract 1 from it. I have 18 times x to the first, so 18x. Again, the derivative of a constant is just 0, minus, and I'm going to pull down the negative 2, 3x, and then I'm going to subtract 1 from the negative 2, so I'm left with 18x plus, because I got a negative, 6x to the negative third, and I could write that as 18x plus 16x over 6 over x cubed. Number 9 is super easy. The derivative of a constant is just 0. And finally, number 10, I've got x squared plus pi. Well, pi is just a constant, so the derivative of that is just going to be 0. And the derivative of x squared is just 2x. So I'm just left with 2x. So not too hard. All right. So hopefully that kind of gives you a nice introduction to how to use the power rule. And you can see that that's a lot easier than the way we did it last class by finding the limits as h approaches 0 of, the function plus a delta and all that stuff. So the power rule is a very, very powerful tool for you. So that's where we're going to stop for today.